All right, so a couple weeks ago we started with Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Remember? And you can take, if you have a right triangle, you can take one leg and square it and add it to the other leg and square that. And if you take the square root at the end of that, it will give you the length of the hypotenuse, which is the diagonal side of the right triangle. So, today we're gonna use that in order to figure out what the distance between 2 points is. On the practice for the state test, there are some problems that say if Julia is at camp and she leaves the camp and she's trying to walk to the cafeteria to eat breakfast before camp activities start. And if she stays on the road, she'll have to walk this many miles. But if she goes through the woods, she'll have to only walk this many miles. So we have to figure out the distance, and we can use Pythagorean theorem to do that. So on this coordinate plane, you have 2 points, okay? So the first thing says A. So we're going to go through these one at a time. It says A, draw a line segment CD using a straight edge, okay? So you're going to draw a line between these 2 points and connect them. Draw the straightest line you can and do your best. On part B, it says, draw in and label point E, which is located 3 units right of point C and 4 units down from point D. Okay? So we're going to call this C, we're going to call this D, and now we're going to make E. So 3 units to the right of C, so I'm going to do 1, 2, 3, and put a point, and I'm going to call this E. And I'm going to make sure that it's 4 units up from D. So 1, 2, 3, 4. Then C says, draw in the 2 legs of right triangle CDE. So I'm going to do that now. So here's one leg, and here's the other. So now I have a right triangle. And it says, now I'm on part D, it says label line segment CE with its length. All right? So that means I have to go from C to E, and I got to count. So I got to count 1, 2, 3. So the distance is 3 on CE. Then it says label DE with its length. So I'm going to count 1, 2, 3, and 4. So the distance for DE is 4. Then it says label point D with its coordinates, which is 9, 11. Now it says part G, using the most important theorem in all of geometry, use the right triangle to determine the length of the hypotenuse. So if we have 2 sides, we can find the missing side, right? So this is my C, this is my hypotenuse. So we're going to use side squared plus side squared equals hypotenuse squared. Or A squared plus B squared equals C squared. Now A and B are going to be my 2 sides. So that would be 3 squared plus 4 squared equals C squared. Now when I work that out, 3 squared is 9 plus 16 equals C squared. And if I add them together, I get 25 equals C squared. Now remember, at the very end, you always have to take the what?
The square root.
The square root. So I'm going to take the square root of both sides. And when I do that, I get 5 equals C. So now I know that my hypotenuse is 5. So H says, what is the distance between points C and D? And the answer is 5. Next it says, label point E with its coordinates, which are 9, 7. So we did that. And then we're going to go down to J. So it says our goal now is to see how to combine the coordinates of endpoint C, which is 6, 7, with endpoint D, which is 9, 11, to come up with a distance of 5. So we want to use our points. All right, so this is the point 6, 7, and this is the point 9, 11, and we need to figure out how we can use those 2 points to come up with C equals 5, instead of having to use Pythagorean theorem. Because if you noticed, it took a little while. And you've got to get graph paper out, and then you've got to plot your points, and then you've got to draw your triangle, and then you've got to do a squared plus b squared equals c squared. So it's a lot of steps involved. It's time consuming. And your state test is a timed test. So you've got to make sure that you get everything done. All right, so let's look at J. K. It says write down only the x coordinates of points C and D. All right? So C is this. Which one of these numbers is the x coordinate?
6.
6. All right? So my answer is 6. And what is the x coordinate for D? 9. So now you have your 2 x coordinates. So it says, notice that the horizontal leg CE is 3 units long. How could you combine the 2 numbers from K to get a result of 3 in the calculator? What process do you have to do? I have 9 and I have 6. How can I get 3? Subtract. Okay? So then it says, write a mathematical expression to represent the idea from here, from L. So it says your expression should have the numerals 9 and 6 in it, and it says put parentheses around it. Okay? So I'm going to put 9 minus 6 and put that in parentheses. Now we need to look at N. And N says, write down only the y coordinates of points C and D. So what is the y coordinate of point C?
7.
7, good job. And what is the y coordinate of point D?
11.
All right. So then it says, notice that the vertical leg, that's your up and down leg of DE, is 4 units long. How could you combine the 2 numbers from N to get a result of 4 in your calculator? Subtract, right? If you do 11 minus 7, you get 4. So we're going to subtract. So now we're going to write that as an expression in parentheses. So we're going to do 11 minus 7. And the parentheses are important. They'll come into play in just a little bit. So Q says, looking at the Pythagorean theorem work from part G, so look up, it says we see the basic equation, which is 3 squared plus 4 squared equals 5 squared. So it says rewrite this equation by replacing the 3 with the 9 minus 6 that we came up with, and don't simplify it, and then replace the 4 in the equation with 11 minus 7. So I'm going to do that now. So we have 3 squared plus 4 squared equals 5 squared. And I'm going to replace the 3 with 9 minus 6. Because those 2 things are equal, right? 9 minus 6 and 3 are the exact same thing. I'm just substituting. And then plus, I have 11 minus 7. Because that's the same thing as 4. Equals 5 squared. So now I've done that part. So now it's still the same, it just looks different. We just substituted something equal to 3 and something equal to 4. And now we're going to take that another step further. One of the things that we do in pre-algebra is learn to deal with letters, right? Variables. Because we're going to see lots of those in algebra. So it says, let's relabel the numbers for points C and D. Instead of numerals, let's use symbols. So we're going to use variables. We'll call point C, point 1, and we're going to label it with an x1 and a y1. So because C is our first point, we're going to call this x1 and we're going to call this y1. And remember, we did this when we talked about slope. Y'all remember that?
Yes.
Okay. So now we're going to do it for Pythagorean distance. So it says, and we're going to label point D as point 2. So this would be x2, y2. And now we're going to rewrite it. We're going to take our equation from Q and we're going to replace the 6, the 7, the 9, and the 11 with x1, y1, x2, and y2. And we're going to replace the 5 with a d. So instead of 9 minus 6 squared, 9 goes with x2. So I'm going to do x2 minus, because I have a minus sign there, and then I have 6. 6 is x1. And then I close my parentheses, and then I square that, because I have a square there. Next I have a plus sign. Then I have another parentheses. And 11, which is right here, goes with y2. So I have y2. And then I have a subtraction sign. Minus 7, which is y1. And then I'm going to square that. And that's equal to d squared, because it says here to replace the 5 with the d. So now we have a formula. Now, I'll be honest. I'm not a formula memorizer, and most of you guys aren't either. So if you don't remember the formula for distance on your state test, use Pythagorean theorem, because I feel like most of you can remember a squared plus b squared equals c squared. But if you have something that looks sort of like this, probably not going to memorize that. All right, so we're going to move on to the back page. So everybody turn the page. And so number 2 says, you should now be looking at this equation, which we are. So it says we're going to rewrite it so that d squared is on the left and the rest is on the right. So I'm going to write d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. So all I did was switch the sides. The d squared, it was on the right-hand side of the equal sign, now it's on the left. And everything else was on the left-hand side of the equal sign, and I moved it to the right. Now it says take the square root of both sides. All right? So I'm going to do the square root of d squared, and I'm going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. So remember that square roots and squares undo each other. They're like opposites of each other. So if I take the square root of a square, I'm going to get just the base. Or so in this case, I would get just d. So when you take the square root of d squared, you get just d. Now, on the other side of this, we can't really do anything with that. So we're just going to leave all that alone. So we're going to have the square root of x2 minus x1 squared plus y2 minus y1 squared. And from here on out, that's called the distance formula. We basically did a proof of how to get the distance formula. When you get to algebra next year, you're going to be expected to do more than just memorize formulas. you've got to know how you get them, okay? Remember when we did Pythagorean theorem and we read the book on what's your angle, Pythagoras, and we actually did we added the two smaller squares together to get the square on the side of the hypotenuse? That was a proof, okay? That's the proof of the Pythagorean theorem. This is the proof of the distance formula. So that's one of those things that you've got to be able to kind of get in a mindset of. We're taking math to another level, all right? I'm trying to get you ready for that. So now we have our distance formula, which is right here. So now we're actually going to work some other problems with that distance formula. So let's look at number 3. So it says, let's apply the formula to figure out the distance between 2, 8 and 7, 20. So those are two ordered pairs. And like I told you, if you don't remember how to do distance formula, I want you just to plot those 2 points, draw the, use a straight edge and draw the hypotenuse, and then make it a triangle, and use Pythagorean theorem to do it. But if you do remember this, it is much faster. All right, so first thing it says, label your points. So since this is my first set of ordered pairs, I'm going to call this x1, y1. And since this is my second set of ordered pairs, I'm going to call this x2, y2. Now I'm going to copy the formula, and it was d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now the next thing I'm going to do is I'm going to substitute these numbers in for these variables. So I'm going to start with d, because that's what I'm trying to find, and then I draw a big giant square root symbol. And then you have a parentheses and another parentheses. Now the reason I did that is because when you put this in your calculator, you've got to use the double parentheses, otherwise you won't get the right answer. So I'm going to start with x2. So in this case, x2 goes with the number 7. And then I'm going to subtract, because that's my next symbol. Then I have x1, which is 2, close parentheses, squared, and then plus, because that's what's next here. I closed my parentheses, I squared, and I put a plus. Now I have another parentheses. Y2 is the number 20 minus y1, which is 8, and then I square that. And then I put my finishing parentheses. Because if you open a parentheses, you got to close it. Now we're going to work all this out. Now you can put this entire thing in the calculator, okay? So I want you to try that next. So I want you to hit the second button on your calculators. Everybody do this. Hit the second. Now hit the x squared button. And you should have the square root symbol and a parentheses. Now I want you to put in another parentheses. 7 minus 2, close parentheses, hit the x squared button, plus, open parentheses, 20 minus 8, close parentheses, hit the x squared button, close parentheses again. And now I want you to hit enter.
13.
X equals 13. Or D equals 13. Very good. So I'm going to simplify this in D, and I'm going to show you exactly what happened. So D is equal to the square root. Now I'm going to start with 7 minus 2, which is 5 squared, plus 20 minus 8, which is 12 squared. Then I can simplify that. 5 squared is 25, plus 12 squared is 144. And then I add those two numbers together, and I get 169. And when I take the square root of 169, I get D is equal to 13. So my distance for this is 13. Go ahead. You can wait till then. All right. So now we need to look at number 4. So it says, now let's apply the formula to figure out the distance between 4, negative 6 and 9, negative 14. So step 1, label your points. Always do this. Always label your points. So my first set of ordered pairs is going to be x1, y1. My second set is going to be x2, y2. Then I'm going to copy down the formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug our numbers in or substitute. So D is equal to the square root. X2 is 9 minus x1 is 4 squared plus y2 is negative 14 minus y1 is negative 6. Now D says this problem is slightly different from before. What is the difference? What's different this time? What do you have right here that we didn't have in the last problem?
Negative.
Negatives, right? Negatives. And if you don't deal with negatives the right way, you get crazy answers. And when you try to take the square root of a negative number, if you made a mistake, it's going to give you an error message on your calculator. Because you can't take the square root of a negative number. It's imaginary. All right, so then it says simplify, being very careful with the negatives. So D is equal to the square root. All right, so I'm going to do 9 minus 4, which is 5 squared. And then I have negative 14 minus a negative 6. So minus a negative, that's like plus 6. So my second part in parentheses would be negative 8 squared. And then when I take that a step further, 5 squared is 25 and negative 8 squared is 64. So I have D is equal to the square root of 25 plus 64. So D is equal to the square root of 89. Now, when you put the square root of 89 in your calculator, you're going to get a decimal, okay, because it's not a perfect square. And when you get that, you would have to round. So your answer wouldn't be perfect, right? Because when you round, you're kind of estimating. So instead of estimating, we're going to leave the answer just like that. We're going to put D is equal to the square root of 89. And that is a perfectly acceptable answer. It's actually more right. Because you're saying it is this thing. You don't have to do any rounding or estimating or anything like that. So if you get a crazy answer, like a decimal answer, I want you to write it like this. D equals the square root of 89 or whatever answer, whatever number it is that you get. All right, so to number 5, you're going to work these 3 problems for homework. You're going to do A, B, and C. Now notice on C it says round to the nearest hundredth. So that's what you need to do. And because you're starting with numbers that are in the 10th place, if we round to the 100th place, it'll make it more accurate. Okay? All right, so that's it. Work on your homework.